In the following two lectures, we are going to study some of the key aspects of the optics, which is necessary to understand the various techniques of spectroscopy and microscopy. So the first things we are going to study is about the state of light polarization. So as we studied already, the light has some electric field oscillation. So in one direction. So when the light propagates, the electric field oscillate. So as you can see that if you have electric field in the XY plane is somehow mixture of the EX and EY. So we can write it down like EX equal EX0 sine KZ. So which is oscillation in the X polarization. So polarize, so electric field direction. And then also EY equal EY0 sine KZ. So which is the electric field oscillation in the Y direction. So by mixture, by combining these two electric fields, you can see in the XY plane that the final electric field is in this direction. So mixture of the synthesis of the X direction and Y direction gives this red direction of the oscillation of electric field. If the electric field of X is phase shifted for pi, phase shifted. So let's think about this. In this case, EX0 sine KZ plus pi. But keep the Y field the same. And then the X field is obviously EX0. So only one of the electric field is phase shifted. So the sign is become opposite. So as you can see in this figure, so only the electric field of X is now opposite. Then what you can see is the electric field of light become the synthesis of the Y direction and the X direction gives this red direction. So meaning that the originally light, the polarization of light is in this direction, change into this direction. So in some cases, we want to do this because we want to control the polarization of the light, and sometimes some specific direction of polarization can give the response of the material. And this could be done by the optics named as the wave plate. So this one, wave plate can control the polarization of the light. And how can we do this is we use a Biopharyngeal crystal. So Biopharyngeal crystal is just by rotating the Biopharyngeal crystal, you can rotate the polarization of the direction. So in principle, so what happens here is if you have a Biopharyngeal crystal, looks like just like this crystal, and if we have X direction and Y direction, this crystal has a different refractive index depending on the direction. So in X direction and of X, and in the Y direction, the refractive index is N of Y. So what you can do is, in the case of the phase shift, so phase difference between the EX field and the EY field, right? So EX field and EY field can be delayed, would make a difference between the phase difference is kg. So if you have k equal k, since the k is a wave number, so k equal 2 pi and d, right? So if you think about the delta k, so the phase difference between the EX field and EY field can be calculated like 2 pi times N of Y minus N of X times D upon lambda. And if this value becomes pi, you can make this phase shift like this. So what you have to do is you have to control the thickness of D, and then you can define the phase difference between the X direction field and Y direction field, and then as a final output, you can rotate the polarization of the electrical field. So similarly, when only the EX field is phase shifted for pi of 2. Let's think about this. So please stop the video and then please write down the EX field and EY field and think about the relation between the EX and EY field. Okay, then what we have to do is EX equal EX 0. And which is equal to now EX0 cosine kz cosine kz, and then Y is still same. So as you can see, that the relation between the EX and the EY is obviously EX squared plus EY squared equal 1. So meaning that the synthesized the EX and the EY field is on the circle, right? On the circle like this. And as you can see, if you draw the EX and the EY field, always EX field is pi of 2 difference. So the thing is, the electric field is actually rotating. Right? So this is circular polarized light. So electric field is rotating as the light propagate. And you can do this similarly as if you adjust this delta k times d equal pi of 2 by adjusting the thickness of the